Hello everyone, let's continue our course. After the PRMN selections, we will perform the cell selections. PRMN selection and the cell selection, we already know, must be based on the MIB SIPs receptions. If UE cannot receive the broadcasting message, UE cannot perform the PRMN selection and the cell selection. UE actually doesn't know which PRMN this cell belongs if UE cannot receive the MIB and the SIP from that cell. So after PRMN selection, cell selection, UE will select the cell and stay in that cell. UE compound that cell until UE receive a paging or user initiate setup services in that cell. After that, UE will perform random access procedures. Random access procedures, the purpose of the random access procedures is to get the uplink synchronizations, acquire uplink scheduling resource. Actually, the random access here is used for the access. UE will use these procedures to set up a connection with the network. Before the random access, UE has no connection with the network. UE stay in the idle mode. UE cannot send any message to the network. After the random access, UE build a connection with the network, and the UE can send message to the network. UE stay in the connecting mode. Random access procedures help UE to build connections with the network. For the random access procedures, we have 6 different scenarios. In these 6 different scenarios, we will use random access. Case 1, initially attached. UE doesn't have any connection with the network. UE stay in idle mode. If UE want to build a new connection with the network, initially UE will do the random access. Case 2, RC re-establishment after RC drops. UE already had a connection with the network, but the connection failed. By some reason, UE will try to reconnect with the network, re-establish a RC connection. This is the case 2. Case 3, hand over to a new cell. Case 4, downlink data arrives in eNode B when uplink out of the synchronizations occurs. Case 5, uplink data detected by the UE when uplink out of the synchronizations. Case 6, when UE trigger the location services. Location services here means the network want to find out where's the UE, try to locate the UE. This location services is a special services, it's optional services. It's not very common in the live network. For these 6 different scenarios of the random access, actually we divide them into 2 classes. One is the contention-based random access. Another one is the non-contention-based random access. For the case 1, case 2, and the case 5, they belong to the contention-based random access. For the case 3, case 4, case 6, they belong to the non-contention-based random access. Contention-based random access, which means UE first randomly select a time slot and randomly select an access preamble and send the access preamble to the eNode B. Because UE randomly select a time, so many UE may access to the eNode B at the same time. So in this case, we may have some conflictions. After eNode B receive the preamble actually is an access request in GSM and the WCDMA system. We have this preamble. We also have this preamble, just like a request of the access. If eNode B receive this request, and eNode B will send the response to the UE. random access response. Usually we call it RAR for short. And then UE will send the first scheduled uplink transmission. If it's in the case 1, UE initially set up a connection in the case 1, then this message, first the scheduled uplink transmission, will be the RC connection request message. Different case, different scenario. In the third message, first the scheduled uplink transmission will be different. In the case 1 I just mentioned, is RC connection setup request message. But for the other case, maybe some other message. And eNode B, if we have some conflictions, eNode B will send the contention resolutions after eNode B receive this message, receive the RC connection setup request message. Okay, this is the contention-based random access. We will have the conflictions. We may have the conflictions in this scenario. Case 1, case 2, and case 5 belong to the contention-based. Contention-based face the conflictions, which is not good for us. For the non-contention-based, there's no conflictions. Why? Because eNode B specify the random access time slot and the random access preambles. Everything is predefined by the network side. So we already prevent the conflictions during the random access. UE, first, actually, eNode B send the random access preamble assignment to the UE. Then, based on the assignment, UE send the random access preambles. Different UE, of course, they will send different preambles because everything is assigned by the eNode B, predefined. Then, eNode B will send the response. There's no contention resolution step for the non-contention-based random access. Before the random access, here, eNode B assign a dedicated preambles to the UE, dedicate for each user. So there's no conflict. Case 3, case 4, and the case 6 belong to the non-contention-based. Non-contention-based random access is very good. There's no conflictions. But why we don't use non-contention-based random access for the case 1, case 2, and the case 5? Why we use contention-based for the case 1, case 2, and case 5? Because case 1, case 2, and case 5, for these 3 cases, there's no connection between the UE and the eNode B. In another way, which means eNode B cannot send or assign the dedicated preamble to the UE. For example, in the case 1, UE initial attach. Initially, UE want to set up the connection with the eNode B. That means before UE access the network, there's no connection between the UE and the eNode B. How eNode B assign a dedicated preamble to the UE? It's impossible. So for the case 1 and also for the case 2 and the case 5, eNode B cannot assign the dedicated preamble to the UE. So that's why case 1, case 2, and case 5, we use contention-based. Actually, if it is possible, we want all the case use non-contention-based. But unfortunately, we have no choice. Case 1, case 2, and case 5, they cannot use non-contention-based. Finally, they use the contention-based. This is the classification of the random access. Okay, RC stator and the transitions. Here in this slide, it mentioned the state of the RC connections. For the RC state, we have 2 different states, RC idle and RC connected. RC idle, which means there's no RC connections between UE and the eNode B. RC connected, which means UE and the eNode B, they already have RC connections. RC connection is a signaling connection between UE and the eNode B. And this signaling connection is the preconditions for our services. Each UE, they only have one connection with their E node B, just the one RRC connection. All the services will be carried by this RRC connection. If this RRC connection is released or disconnected abnormally, all the services of this user will be dropped. When there's no connections, UE cannot send any message to the network, and we call it RRC idle mode. In the idle mode, UE will perform those actions. For example, monitoring the paging channels. For example, perform the cell reselection procedures. Receive the system information. Here, system information means broadcasting message. For example, MIB message and the SIP message. UE will read or receive the MIB message and the SIP message. In the connected mode, UE and the E node B, they have connections. And the UE will perform those actions. For example, mobility management. Here, mobility management means the handover procedures. And also, data transfer in the uplink and the downlink. That's the very common actions for the connected mode. If UE want to enter the connected mode, UE must set up RRC connections. Before the RRC connection setup procedures, we will perform the random access procedures. Actually, the random access procedures is triggered by the paging or initially triggered by the users. After we set up the RRC connection, from here, UE enter the connected mode. When UE set up the RRC connection, also E node B will set up as one signaling connection with the core network. RRC connection actually is a connection, it's a signaling connection between the UE and the E node B in the air interface. RRC connection plus the S1 signaling connections. Then, in total, bound up, and we have a connection from the UE to the MME. After these connections, RRC connection plus S1 connection is set up successfully, UE and the core network, they can communicate with each other. After that, UE and the core network, they will use NAS signaling to communicate between each other. For example, they will start the authentication procedures and the security mode. After the authentication and the security mode is finished or succeed, they will set up the ERAP. ERAP setup is just like a services setup. ERAP establishment actually is the services establishment. After that, UE can start the services, start the conversation or start the downloadings. After the services is finished, we will have ERAP release and the signaling connection release. This is the signaling connection establishment procedures we just mentioned here. The signaling connections has two parts, RRC connections in the UU interface and the S1 connection in the S1 interface. And this is the protocol layers for the control plane. In the UU interface, we have the protocol. In the S1 interface, we also have different protocols. This S1 interface protocols is based on the TCP IP. But UU interface protocols, all of these protocols, physical layer, MAC layer, IRC layer, PDCP layer, and RC layer, they're all defined by the 3GPP. They are totally different with the TCP IP structures. MAC layer, IRC layer, and the PDCP layer, we consider them as the layer 2 of the UU interface. Physical layer, we consider it as the layer 1 of the UU interface. RC layer, we consider it as layer 3 of the UU interface. In UU interface protocol stack, we have 3 layers. Layer 1, layer 2 from MAC to the PTCP, and the layer 3 RC. Let's have a summaries for these sections. First, we discuss the PRMN selections and the cell selections after UE power on. These two procedures is very common for the UE. UE will first do the PRMN selection and the cell selections. After that, UE will stay in the cell where UE selected. And if UE receive a paging or the user initially set up services, UE will perform the random access procedures, try to build a connection with the network. After that, we will have the RC connection management procedures. That's all for these chapters. Thanks for watching.